Hey, algebra students. In this lesson, we are going to be factoring trinomials using the greatest common factors of the three terms in the trinomial. Here's what I mean by that. Take a look at letter A. P to the fifth plus 13p to the fourth plus 12p to the third. That's a p to the third right there. It's a little difficult to see. That would be a really difficult trinomial for us to work out because the exponents are weird. Usually we're used to dealing with something to the second plus something times something to the first plus something to something that doesn't have a variable at all. What can we do with this one in order to make it easier to factor? Well, we could notice that all three of these numbers have a factor in common. Okay, I noticed that all of these have a p that can be factored out. So here's how these problems are going to work. I'm going to show you on letter A, which is a really easy trivial one, and we'll take a look at letter B, which is a little more complicated. We'll just kind of go down the list. Now, in letter A, what can I pull out of all three of these? Now, I could, if I wanted to, make a factor, like our prime factors, or no, let's see, yeah, do prime factorization on each of the three terms, and then notice which factors each have in common and pull those things out. We're going to do that for the second one. For the first one, I'm just going to note there's a shortcut way to do this. If you could just see which factors can be pulled out of everything, you could just pull that out front. So I noticed that p to the third can be pulled out of everything here. So I'm going to do is I'm going to put a p to the third out front of a set of parentheses, okay? You have to do this. Whatever you pull out, you need to make sure it goes in front of a set of parentheses. Now, in my parentheses, I'm going to put the remaining term after I pull out p to the third. It's going to be p squared plus 13p plus 12. Okay? P squared, because it was p to the fifth, I pulled out p to the third, plus 13p, I pulled out three of the four p's up front, and then p to the third got pulled out, so my last term is just 12. Now this, in parentheses here, looks like a trinomial that I've dealt with before. And this up front is just going to get carried along for the ride. It's never going to change. So my next step, I'm actually going to factor my trinomial. So I have p to the third up front. It has to stay as one of the terms in my expression times p plus something, p plus something. I know these are both going to be pluses because everything's a plus in here. Now, what are the factors of 12 that add up to 13? At this point, you should be good enough at this. You're like, well, 1 and 12. And this is my factored trinomial for the first problem. P to the third, p plus 12, p plus 1. I switched the order here, but that's totally fine. Let's move on to letter B. Now, in letter B, I'm going to show you the fail-safe way to do this in case you can't figure out what to factor out. 6n to the fourth. I'm just going to list my factors, my prime factorization of 6n to the fourth. That's 2 times 3 times n times n times n times n. There we go. And then 6n to the third is 2 times 3 times n times n times n. And then we've got 12n to the second. That's 2 times 2 times 3 times n times n. All right, now for prime factorization, remember how this works. I'm going to find my factors that are the same all the way down. So I've got 2, 2, and 2. I've got 3, 3, and 3. And then I've got two sets of n, and n. Okay, there we go. So now I'm going to multiply those things I pulled out back together. 2 times 3. This 3 is included in there. Maybe I just want to move this over a little bit so it's really obvious that that 3 there is being included as well as the top 3. All right, anyway, 2 times 3 is 6 times n times n. The thing that I'm pulling out front is going to be 6n squared. That's what these terms have in common. But I can't forget the rest of my term, okay? So what does that leave? If I pull 6n squared out, in the first term, I still have an n squared left over, the two n's that weren't accounted for. So I'm going to put n squared back in there, all right? Now I need to look at my symbols. It's a minus symbol next, so I need a minus in my term here. And then let's see, the next thing is going to be just regular old n, minus n, and then a minus again. And in my last term, the only thing I had left was a 2. There we go. So it's going to be 6n squared times n squared minus n minus 2. I notice that this last term is negative. That means that we're going to have 6n squared comes along for the ride. Need to make sure I keep including it. Okay. Times, and then it's going to be n plus something times n minus something. And these things have to be factors of 2 that add up to negative 1. Well, the only factors of 2 are 1 and 2. To make that add up to negative 1, I'm going to do n plus 1, n minus 2. There we go. So that is going to be the correct factorization for letter B. Let's take a look at letter C. Letter C is proving a point, okay? Hey, if I start off with a negative r squared, by the way, this is really important because this is going to come up again and again. If I start off with a negative r squared, I can't deal with a negative first term. That's going to throw off the whole trinomial. So what I'm going to do instead is factor out that negative in front of a set of parentheses. That's kind of what we're doing with all the other ones. Now, because I'm factoring out that negative, all of the other things are going to change their signs. So it's going to be negative r squared, okay, minus r minus 30. Notice that now my first term is positive, and that's what we're used to doing. So now that negative is just going to come along for the ride. It's going to be r plus something, r minus something, okay. And now plus what, minus what? Well, let's see. Factors of 6 that add up to negative 1 when we add one and subtract the other. This is going to be r plus 5, r minus 6. Now notice I'm not making a list of all my factors here. That's a trick you can use if you can't figure one of these out, if you get stuck. All of these have been really easy to figure out so far. So notice I have my negative up front, r plus 5, r minus 6. If I were to multiply all of this back together, it would take me back to my original term. All right, letter D. So letter D is also going to be a straightforward one where we've got we're going to have to pull a negative out front. But I'm just going to notice a couple other things. I notice all of the terms have a D in them, so I can pull one D out front. And all of the terms have a multiple of 5, which is really obvious. Multiples of 5 are really obvious. So I'm going to pull a 5 out front. So what I'm going to pull out front is negative 5D. And then instead of going through all of these steps that we went through in B, which I could do if I got stuck, okay, I could do the prime factorization of 5D cubed, 25D squared, and 20D, see what they all have in common, multiply the things they have in common together to get my greatest common factor that gets pulled out front, and then just list what I have left in each term. I could do that, but that's a lot of work. Can't I just instead go through and see what it would be left over if I pulled out a negative 5D? In the first term, I'd just be left with d squared. Okay, that's really handy because I know how to solve this type of problem. Now the sign they're going to change because I pulled out a negative. So next I'm going to have plus 5d for the middle term. I pulled out a 5d out of 25d squared. I get 5d. And then lastly, it's going to be plus 4. You pull a 5D out of 20, you just get regular old 4. 4 times 5D is 20D. If I multiply them back together, I get that last term again. All right, that's it. Now, we're going to do, it's all pluses inside the parentheses. That's one of the easiest types of setups. So it's going to be D plus something, D plus something. What are the factors of 4 that add up to 5 when I add them both? Well, easily that's going to be 4 and 1. 4 times 1 is 4. 4 plus 1 is 5. This is the factorization for letter D. I haven't been showing the answers, but let's just check the last 3 to make sure we did them right. That one's good. This one's good. I even got them in the right order. And then this one's good as well. All right. Let's go on to letter E. We're going to move our work over to this side of the page. All right. In letter E, what can I pull out of all three of these? Well, the only thing I can pull out of all three of these is a XY or YX, right? I wonder what that's going to do to our problem if I pull a YX out front. And I'm going to just do it in that order because they did it in the order YX. So let's see, YX. If I pull a YX out of the first term, I get Y squared. Okay, so far so good. It's nice to have a regular square term to start off. Plus, if I pulled a YX out of the second term, I'm going to have plus 3Y. Okay. And then in my last term, if I pull yx out, I have nothing left other than my constant, which is 54. Okay. So now I can simplify this. Yx comes along for the ride, and then it's going to be y plus something, y minus something to make negative 54 as the last term. Okay, so what's it going to be plus and minus? So I have to think of the numbers that I can multiply together to get 54. Here's one where 54 is a little tougher. I'm going to list out the factors. 54 could be 1 and 54, but that doesn't seem very likely because that's going to give me big numbers. It could be 2 and 27. Still really big numbers. I can't get a 3 out of that. It could be 3, right? And is it 18? Still way too big numbers. That'll give me like that'll give me like a 15, but I need a 3. All right, let's think about this. I don't think 4 goes into 54. 4 would go into 52, not 54. 5, no. 6 goes into 54 9 times. 6 times 9 is 54. And there I think we're going to have it because I noticed the difference between these two numbers is a 3. So this is going to be y plus 9, y minus 6. And that's my answer. Let's just double check, make sure I got it right. There it is.